Problem 29. Surgical complications. A medical researcher wants to construct a 99% confidence interval for the proportion of knee replacement surgeries that result in complications. An article in the Journal of Bone and Joint Surgery suggested that approximately 8% of such operations result in complications. Using this estimate, what sample size is needed so that the confidence interval will have margin of error 0.04. So in the problem, we need to pay attention to the question. They're asking us to find the sample size. The formula to find the sample size when p-hat is available is this one. And when p-hat is not available, we will use the second one. For problem B, we estimate the sample size also, but p-hat is not available. So for problem A, we will use the first formula. So the sample size is what we try to find the number of the data for us to collect so that we make sure the margin of error is this number, the confidence interval is this number. Okay, so p-hat is available and that is 8% and that is 0.08 and I just plugged them in. The margin of error is 0.04. To find z, we need to draw the graph for the z distribution. The confidence level is 99%, so the tail is 0.5%, which is 0.05 for both sides. And then you can find the GeoGebra Classic. And then I click on the probability. You can use either the right side or left side. And we put in 0.05 for the probability. And we got the number is 2.5758. The other side is negative 2.5758. Now you put in 2.5758, either positive or negative, because when we square, we will get the positive answer anyway. So we will input those number in the calculator. So I use the GeoGebra Scientific Calculator. Then we have 0.08 multiply 1 minus 0.08 and then multiply on the top is 2.5758. In the bottom we have 0.04 and then exponent square. So we got the answer is 305.19. So we are finding the number, the number of the data. In this case, this is the number of the surgery, so it has to be a whole number. We got the decimal number, but we want to make sure the margin of error is 0.04. So we read this part in the formula. It said that if the n is not the whole number, we need to round it up to the nearest whole number. And because we round it up, we can be sure that the margin of error is no greater than the desired value m. In our case, is 0.04. So we round up to the nearest whole number is 306. Now in part B, because p-hat is not available, so we use 0.25 times z divided by m square, and 0.25 times 2.575a divided by 0.04 square. Okay, we input that into the GeoGebra, and 0.25, and it's give us 1036.67, and so on. And also we round up. So first of all, the 0.25 is come from p hat. If we don't know p hat and 1 minus p hat, we assume that p hat is 0.5 when we don't know, and 1 minus 0.5 is another 0.5. So 0.5 times 0.5 is 0.25. That's what the 0.25 come from. And when we don't know p hat, the data that we need to collect, the number of the surgery that we need to collect is 1037. When we know p hat, we only need to collect 306. So you can see that the p hat, when it's not available, we have to collect more, which is it take more work and more time.